All right, chapter 4 starts today. First 3 lessons, we're starting in 4.2, not 4.1. There's really nothing to do in 4.1, just a bunch of things. 4.2 is where it really begins here. So we're going to run through each of these terms here: factors, primes, composites. What's a factor? We know what factors are. Roland?
Are numbers that are multiplied to find a product.
So, what? In your own words?
Numbers that are getting...
It's the number inside a multiplying problem. If I say 5 times 1 equals 5, what are my factors? Right, both of these are factors. And then this is called my
answer or quotient.
Quotient is when you divide.
And then thumb.
I'm so close. I'm so close.
So a factor is a number in a multiplying problem. Factor. The product is the answer to a multiplying problem. So there has to be at least 2 factors to multiply. I mean, you can't just, if I just write the number 7, well, that's not a multiply, that's just the number 7. So you got to have another number. 7 times 2. Okay, that was fact. And you could have lots of factors. I could have 7 times 2 times 8 times 12 times, we don't have to solve that, but 7, 8, 2, 12, those are all factors. There's no limit to how many factors there are, but there's only one product. There's only one answer. So the factors, and we're going to deal with that. We're going to deal with greatest common factors. Factors is a huge word, term. We need to understand what it is and what it means. Okay? Prime numbers. Prime numbers have exactly 2 factors. Exactly 2 factors. So if I wrote out the number 7, okay, what times what equals 7?
1 times 7.
Yeah, 1 times 7. Or I could write, the order I write it doesn't really matter. What else? That's kind of it, right? So if I would say, what are the factors of 7? I would say, so if I say, what are the factors of 7? You would say 7 and 1, or 1 and 7, doesn't matter, because that's it. If I said, what are the factors of 13? What are the factors of 13?
1 and 13.
1 and 13. So, exactly 2 factors, right? And what are the 2 factors? The 2 factors are 1 and itself. That's it. Because 7, 1 and 7. 13, 1 and 13. We're only talking whole numbers here. So, you could say 3.5 times 2 is 7. Well, that's true, but whole numbers, not weird fractions, decimal type things that multiply to something. Okay? So, your sheet that I gave you there, all those numbers that are in green are prime numbers, meaning they only divide by 1 in themselves. Look at them there. interesting thing you'll see is even numbers. Right? The only even number that's prime is 2. We're going to come back to this sheet, but for now, all these numbers in green are prime numbers. The only numbers that they divide by are themselves and 1. That's it. They have 2 factors. That is it. Okay. Composite numbers. Composite numbers have 3 or more factors. So, and that's what separates prime from composite numbers. Being able to differentiate between them is a big deal. It's a major deal because we're going to be doing prime factorization here in just a little bit. And we do this every year. It just gets bigger numbers. The process never changes, but the numbers get larger. But 3 or more factors. So if I take the number 6, all right, what times what equals 6? Noah. 2 times 3. What else?
1 and 6.
1 times 6. So if I would say, what are the factors of 6? The factors of 6, you would write, in no particular order, mind you, 1, 2, 3, and 6. Those are the factors. There are 4 of them. Number 6 has 4 factors. What about the number 9? Uriah.
It has 1, 3, and 9.
Correct. 1 times 9 and 3 times 3. So if I say what are the factors of 9, I would say 1, 3, and 9. Those are my factors of 9. Composite has 3 or more. 6 had 4 factors. 9 had 3 factors. Some numbers, have tons of factors. 48, 64. It goes. There'll be 10, 12 factors for some of these numbers here. But we're trying to differentiate the difference between prime and composites. And you'll learn why here in just a minute. But composite numbers have 3 or more factors. Prime, it's only itself in 1. So again, if we look at our sheet here, all the numbers in white are composite. Now, number 1 here, by the way, is considered neither prime nor composite. It's a weird number. Okay, so don't worry about 1. 2. 2 is the only even number that's prime. Every other even number is composite. All of them. Because, think about it. Any of these can be 8 times 1, 6 times 1, 14 times 1, but any even numbers also have to divide by 2, right? So at the minimum, you're probably going to have, except for 4, which is 2 times 2, 1, 2, and 4, it's 3 factors. You're probably going to have 4 or more factors for all these even numbers. Like 12. How many factors are there of 12?
There's 2, there's 6.
2 times 6.
Yeah.
12 times 1. 3 times 4, that's 6 factors. 1, 2, 3, 4, 6, and 12. Those are all factors of 12. There's 6 numbers. All right. And on it goes here. Yes, you're right.
5 is the only number with a 5-digit to be a prime number.
Truth. One number I'm going to point out to you that's a little... Knowing your rules of divisibility is critical here. Now, all you really need to know, for the most part, is does it divide by 2, 3, or 5? And I've told you this before. When we did it, those 3 rules can get you through this entire 3 chapters here without too much stress. You need to know, do these numbers, does it divide by 2? Does it divide by 3? Does it divide by 5? How do I know if a number divides by 2?
If it's an even number at the last digit.
Right. In the ones digit, there's a 0, 2, 4, 6, or 8. How do I know if a number divides by 3? You're right.
If you take all the numbers up, and if they equal anything that can divide by 3, it is 3.
Correct. That is right. And 5,
Is 5 or 0?
yeah, if in the 1, 0, there's a 5 or 0. So those 3 rules, if you can remember them, you're going to be set for these 3 chapters. Okay, I promise you that. So one number I'm going to point out here on this whole sheet, because we have our rules of divisibility, but there's one number on here that is composite that none of the rules apply to. Anybody have an idea what number that is? There's a composite number on here that doesn't divide by 2, 3, 4, 5, 6, 8, 9, or 10.
1.
Not 1, because 1's neither.
What digit is it?
The 90s.
Oh. 93.
Adds up to 12, divides by 3.
94.
Divides by 2.
95.
Divide by 5.
91.
91.
Oh.
Because it doesn't divide by 2, 3, 4. What, besides 91 and 1, what times what equals 91? Tough. 13 times 7. So 91's a weird number, because every other number on here, your 2, 3, or 5 rule of divisibility, you can use. Right? I mean, pick any number on here, you could see clearly it divides, either add up, divides by 3, it's an even number, divides by 2, a 5 or 0 divides by 5. All of them. Right? Except for 91. 91's different. So I'm pointing this one out to you. You may see 91 at some point, but 91's weird because it's 13 times 7. We don't have rules for 13 or 7. That's why 91 doesn't really fit well, because it's like in English where you're trying to learn weird words that have odd sounds, that don't make sense with the grammatical language. Why does these letters make this type of sound all of a sudden? It's just sight words, they call them. But this is the same thing, like the sight number. This one number. This is the only number I'm highlighting here for you. The rest of them you can figure out 2, 3, or 5. So let's look at our book here, page 136. It says list all the factors of the number and then tell whether the number is prime or composite. So let's start with number 3. It says 13. So first it says list all the factors for the number. Basically, what's all the things that what times what equals 13. And you can reference your sheet if you want. I mean, prime numbers are only themselves in 1.
1 and 13.
Right, the answer is, what are the factors? 1 and 13. Part 2, is that a prime or composite number?
That's
Prime, because the only things it's divisible is 1 in itself. Number 6, 49. What are the factors of 49? If I reference my sheet briefly, I see that's a composite number, which means there's a minimum of 3 numbers. Could be more. But all composite numbers have 3 or more factors. So when you're doing these and listing the factors, the easiest ones are the ones that are forgotten the most often. I don't know why. On quizzes and tests, it's just, I don't know why. The most obvious factors you would start with are 1 and 49. Every number is divisible by 1. All of them. All 100 of them are divisible by 1. So whether it's prime or composite, the first thing I usually write is 1 and whatever the number is. Because if you don't have those 2 numbers, well, then you don't have all the factors. Especially if it's a one that has like 12 factors in it.
Oh, geez, yeah.
But what else?
It's divisible by 1, 7, and 49. And if there's a 3 for the single digit of the number, it's probably prime. Since 3 has the most primes.
Okay. I agree. 149 and 7. What about number 7? 57. What are the factors? Welcome back. How'd it go, George? We just started not too long ago. Here, I'll take that. I'll trade you. Give me your test. I'll take that. I put a little sheet on your desk for you. That's the first page of notes that we did. Kind of our vocab. As you see, you can watch the first 15 minutes if you want, but real quick recap. We're talking about what's a factor, what's a prime number, what's a composite number. In that sheet I gave you there, all the numbers in green, those are all prime, and all the numbers in white, those are all composite numbers. So you can keep that sheet there, and then here's our second page where we're at so far here. All right, 57. Help me out here. Stella's not going to help me. She's not here. Lauren, what are you thinking?
Obviously 1 and 57.
Good. Anybody, what else? 3.
And 4.
3 times what?
Yeah. 3 times 4.
3 times 4 is 12. I got 57.
Because it added up.
Right, right. It does divide. That tells me it divides by 3. But now what's 3 times, or 57 divided by 3? We know what 60 divided by 3 is, right?
Yeah.
20. And now 57 is just one less. 19. There they are. 1 and 57. The order you write them, if you want to write them out this way, that's fine too. If this helps you to just write it as a multiplying problem, that's fine. I don't care. This is good. You can write them in the order. I don't care. What I do care about is I see these 4 numbers somehow, some way. However you got them or want to write them, I don't care. That's not being challenged. Try number 15. 32.
Yeah.
You can start on the first page of notes if you want, or where if you want to, whatever your plan is. You missed the first 15. I gave you the notes there. So if you feel like you remember this stuff and can just jump in and catch up, cool. If you need that first 15, you can just watch it at home and it should answer all your questions, I think. All right. Anybody have anything for me? I'll open it up. Uriah?
So 32 is divisible by 1. 32. 2, 4, 8, and that's all I got.
2 times what?
Oh,
2 times what?
16.
2 times 16. 4 times what?
8.
How many factors am I up to?
7.
And if you left it that way, hey, I love it. That's great. I need all 6 of these numbers, though. If you rewrite it this way, that's fine too, or whatever you want to do, or write it this way. You understand, I think, at this point here. I don't care. All I care about is those 6 numbers make it onto your paper. You okay with this concept?
Yeah.
How this works? Okay. You can use your sheet. You won't be able to use it on the quiz. You cannot use it on the quiz. But you were very much encouraged and can use it with the homework in class, things like that. I'll tell you right now, the main prime numbers we care about. All right? These are the ones that matter most, and you're going to find out why in just a minute. 2, 3, 5, 7, 11, and maybe 13. But truthfully, these 4 right here are the big ones. You're about to find out why.
I
Yes.
wrote down every single prime number on the sheet on my notes.
Yep, that's fine too. What you need to do to make yourself ready is for you. George, here's the last part. Composite with that